This time we're going to look at the anatomy of a hypothesis, meaning the different parts and a little bit of the vocabulary, and you are going to want to write this down and have it for your references. No numbers this time. Well, there'll be some numbers. No real math. A hypothesis, or anytime we do a hypothesis test, we need to identify two different things. One is the null hypothesis, and that is that the average of the population that we're looking at is equal to a particular number. In the example we've been looking at so far, Jefferson College students are smarter than average. In the last video, we assumed that they weren't. We assumed that the average was equal to 100. That's the null hypothesis, okay? That the average IQ for the Jefferson College community is equal to 100, meaning mu naught means the number that we're talking about. The alternate hypothesis is that the average IQ for Jefferson College students is greater than 100, okay? The average for whatever population is greater than whatever number we're talking about here. So I claim that Jefferson College on average is smarter than average. The thing I'm arguing against is the null hypothesis, which is that they are equal to average. Okay, the null hypothesis always has the equal sign. The alternate hypothesis will be either that Jefferson College students have higher IQ, or that they have lower IQ, or just that they're not average. Right? Sometimes the claim will be that your population is higher than something, sometimes it'll be that they're lower, and sometimes it'll just be that they're not equal to. Okay? So alternate hypothesis is always going to have an inequality. If it's a one-direction inequality, greater than or less than, we call that a one-tailed test. If it's not equal to, then it's two-tailed. Let me show you why. When we're talking about a distribution here, and I'm saying we are not, quote unquote, average, we are not equal to whatever that number is. If we're claiming that Jefferson College students are smarter, then we're claiming that they're up here in this tail. If we say that they're less smart, then we're saying that they're down here in this tail. So in this tail or in that tail. Whereas this one is just saying, I don't think that they're average. I don't know if they're up here or if they're down there. So we call that a two-tailed test. You're not going to need to write this a bunch. It's going to be something we'll be putting in the calculator in just another video or so. So let me run through a couple examples here. A program at Jefferson College claims that the average income of its graduates is $45,000. I think that's high, and I want to test to see if that's actually true. So the null hypothesis here would be that the average income is equal to 45K, right? The college is claiming that it's equal. That's a null hypothesis. The alternate is what I'm going to try to show to test to see if it's actually true. I'm not calling them a liar. I'm just saying I want to do a study to find out if that's actually the case. So my alternate hypothesis is going to be that mu is actually less than 45K. I'll try to show that this is true. If it's not, then I will accept that claim. If I'm able to show that it's less, then I'm going to have to reject that claim. Okay, let's look at a couple more. The college claims the average commute time is 25 minutes. I'm curious if that's true. I don't know if it's high or low. So again, the college's claim is that the average commute time is equal to something. So they're saying it's equal to 25. That's our null hypothesis, that the average commute time is equal to 25. I want to know if they're right. I have no idea if they're high or if they're low. So the alternate hypothesis I'm going to try to show is that the average commute time is not equal to 25. Right? And again, I'm not trying to call them liars. I'm curious if they're right or not. So I'm going to attempt to show this. If I succeed, then I've called their claim into question. If I don't succeed, then I'm going to accept their claim. Now you try this before I do it. Again, you can pause while you try to figure out what it is and then pick up after. A study concluded that the average teenager spends 120 minutes per day on the internet, but I think that's high. So what's the null and what's the alternative, or the alternate? The null would be that the average amount of time teenagers spend online is 120. I think that's high means that I think, and I'm going to try to show that the average is actually, no equal there, is actually less than 120. So my null would be that the average is equal. The alternate would be that the average is less. My friend claims that the average number of pine cones on a tree is 437. I'm curious to see if that's true. So the null hypothesis, my friend thinks that is equal to 437. I'm curious if that's true. I didn't say I thought it was high or low, so I'm just going to check, or I'm going to try to show that it's not 437. If I succeed, I'm going to reject his claim. If I fail, then I will accept his claim, his hypothesis. Okay, that's how the null and the alternate hypothesis work. And we'll talk more about that next time.